Unfortunately, there is a bug that you may encounter as you attempt to integrate the SDK into the Microsoft C# IDE. If you see the error message on the screen as you attempt to integrate the SDK into your project, you will need to edit the file common.xsd. This file is part of the SDK and is located in the directory /SDK/API/XSD. Change the line shown on the screen by removing the following text string: min occurs equals 0. This text is located on or around line number 658. The min occurs value is illegal in this context. In order to include the XML SDK files in your project, place the following instructions at the beginning of your C# source file, using project name .switchWSDL followed by a semicolon, and using project name .XOSWSDL also followed by a semicolon. Exploring the WSDL files. Once integrated into your project, you can explore the objects in the WSDL files by using the class view. We'll skip the fundamentals about the C# programming language and get right to the meat of this training module, which is how to do something with the ExtremeXOS InSite XML SDK. Before your program can make the switch perform any operations, it will have to make a logical connection by opening a session to the web service that is running on the switch. The web service on the switch enables developers to get information, set configuration parameters, and instruct the switch to perform certain actions using XML, SOAP, and TCP/IP as a transport. When you integrate the XML SDK into your C# project, you implicitly loaded support for all these underlying protocols. Connecting your program to a switch involves 2 steps. Step 1. Create a network handle to the web service. XML defines a service endpoint as a port type. You can think of a port type as being analogous with a Java class, in that it is a collection of operations and messages. To connect to a service endpoint on an Extreme Network switch, you need the target switch's address. Once you have that, you can create what Microsoft calls a channel. This channel is nothing more than a handle to the network connection. To create the channel, you must concatenate the URL prefix http:// with the target switch's address and the string /XML service. This string is then fed into a method that creates a new system.serviceModel.endpoint address object. You can see this demonstrated on the screen. Next, an object is created to capture the port type information using the new switch port type client method. And finally, the create channel method is used to create the handle. In the code on the screen, the program stores the information about the channel in the temp PT client object, after the create channel method creates the channel. In the code on the screen, the program stores the information about the channel in the temp PT client object, after the create channel method creates the channel. Now that you've created a communication handle, or channel, you need to complete the process by opening a session with the switch. The first step in opening a session is to create a session object. As you can see, the code for creating a session is pretty straightforward. After the session object is created, you need to add the username and password information to the session object. You can see this demonstrated in the code on the screen. Now that you have a session object, you need to create a request object that can be sent to the switch. Once the request object is created, you need to put the session information into the session request object. In a step that is unique to C#, we have a shadow method that wraps around our original request object. You'll find that any method that involves communication between the client application and the web service on the switch has a shadow version. Finally, feed the two open session requests, with one encapsulated in the other, to an open session request. As you can see, you can capture the response from the request and then, finally, pull the session information out of the reply. You can use your newly created session to actually do something, like create a VLAN. The first thing that you need to do is create an object that will hold the attributes you wish to give the VLAN. The next thing you need to do is to populate the VLAN object with the name you wish to give it, as well as the virtual router to which you wish to assign the VLAN. Now, create a request header to hold the session information you will need to facilitate the communications between the client and the web service. Next, format the create request. Remember, you'll need to create the request and its associated shadow version. Finally, send out the request. If you create a VLAN, at some point you may also need to delete it. Just like when you created the VLAN, you need to create an object that will hold the attributes for the VLAN you wish to delete. Now, populate the VLAN object with the name of the VLAN you wish to delete. The next step is to create a request header to hold the session information you will need to facilitate the communication between the client and the web service. Next, format the delete request. Remember, you'll need to create the delete request and its associated shadow version. Finally, delete the VLAN. To summarize, in this training module, you learned how to provide an overview of the ExtremeXOS InSite XML SDK. List the various pieces you will need to build a Microsoft C# development platform. Integrate the SDK into a Microsoft Visual Studio Express 2008 C# environment. And write a program to create and delete a VLAN on an Extreme Networks switch. This is the end of this training module. Visit the Extreme Networks website for information about our other exciting networking products. Extreme Networks. Tomorrow's network, today.